Okay, what's going on? So in today's video, we're going to talk about factoring. Okay, so we talked about polynomials in the last one, and now we're going to deal with polynomials and how to factor things out. So if you remember in the last video, we did a lot of manipulation, addition, subtraction, multiplication. So if we're talking about today, what we're trying to do is the opposite of multiplication with polynomials. So with multiplication, that was the distributive property, right? We're distributing things uh, into the equation by multiplication. And here we are going to factor things out. So the opposite, okay? So there are more or less six ways of factoring. Greatest common factor, grouping, trinomials, general trinomials, differences in two squares, sum, difference in two cubes. This might seem overwhelming for you if this is all new material. So I'll try my best to take it nice and slow. In this video, we're only going to focus on the first four. So the greatest common factor, or in other words, you might know it as GCF. We're going to talk about grouping, trinomials, and then general trinomials. Okay, we're going to save the other two, 5 and 6, for a different video. And if you're very comfortable and familiar with any of these, like greatest common factor or grouping, feel free to skip ahead to the slides where I talk about trinomials and general trinomials. Other than that, we're going to start off with the greatest common factor. An expression or an equation, go through these steps. So first, go through greatest common factor, see if that's applicable. Okay. Second, if greatest common factor doesn't work, or if you applied it, check if you could group. If you could still group, good. Go with that. Now, in some cases, greatest common factor and grouping might not work, or that's not the end all. In which case, then you're going to have to move on to trinomials, and then, of course, you could use general trinomials for any type of quadratic polynomial equation or expression. So let's move on to trinomial methods of factoring, from greatest common factor to grouping, trinomials, and general trinomials. When you're dealing with general trinomials, you eventually deal with sometimes greatest common factor, but more or less you're always going to touch grouping. And the work order is every time you come across problems like these, you should take a look first if you could use greatest common factor, and then grouping, and if those two don't work, then move on to trinomials or general trinomials. Okay? I hope this video. So by no means, these are just example problems. It's very rare when you come across problems in tests or homework that things are going to be laid out to you like this. Hey, use greatest common factor and so on and so forth. You're just going to have to put in the practice and you'll just get comfortable with it. And yeah, so talk about greatest common factor. What does that mean? All right. So common factor, well, that means in all the terms. So in this first problem here, 6x to the 7th power plus 3x to the 4th minus 9x to the 3rd power, we're trying to take a look at all three terms, right? And trying to see what they share together. And we're trying to see how much of each thing they share. For instance, in this first expression, we have all three terms have an x component, right? Well, how many x's can we do they share in common? Well, this first term has 7 x's, this second term has 4, and this third term has 3. Well, if we're taking a look at what they all have in common, they all could share 3 x's, right? So we could factor 3 x's out of each term, okay? Hence, greatest common factor. So we could pull out an x, but let's take a look at the constants. Or, sorry, not the constants, the coefficients. Can we factor out any coefficients from each term? Well, we have a 6 in the first term, we have a 3 in the second term, and a -9 on the third term. So they all have 3 in common, right? So if we're keeping track, we could factor out a 3, and we could factor out an x to the cube power, or x cubed, sorry. So let's do it one step at a time. Let's factor out a 3 first. So I'm going to say 3. Let me not do that. Let me use white. 3x7 plus x to the fourth minus 9, oh, sorry, 3, because I'm factoring out of 3, and, oh, I apologize, I am messing this up. This should be a 2, x to the 7th plus x to the 4th minus 3x cubed. Okay, so we factored out the 3 part. Now let's continue on and factor out the x cubed, right? Because we could, each term can afford to factor out an x cubed. So then the 3 is there because we factored that out. X cubed, okay, it goes out of the parentheses. So what are we left with the first term now? Well, that is now 2x, so 7 minus 3, we're left with 4, okay? Remember your laws of exponents, plus x minus 3, okay? So now we're looking at that, and if we're looking inside the parentheses, it should all be factored, right? There's nothing else left in common between the coefficients or the x's. All right, so let's give another, this second equation or expression, sorry, another shot. So if you want, pause the video right now and try it out yourself, and then resume when you're ready. So this one's laid out very nice. So what do they have in common? First of all, we have 2 terms, right? This first term, 2x times a quantity of x squared plus 1 to the 3rd power. And then the second term, negative 16 times a quantity of x squared plus 1 to the 5th power. So what do they have in common? Well, from what I see, each term has x squared plus 1, right? So we could yank out or factor out an x squared plus 1, but pay attention that the x squared plus 1 in each term are raised to a certain power. Well, it seems like we could afford to factor out an x squared plus 1 to the 3rd power on both, right? So here we'll be left with x squared plus 1 to the 2nd power after we factor it. So let me just do that. X squared plus 1, I'm factoring that out, and I'm factoring out 3 of those from each term. So I put a cube up there, and then what I'm left with is, okay, so let's take a look. The first term is 2x, and then minus 16, and x squared plus 1, because we still have that left over, but now it's squared, right? You see how that happened? So we removed 3 of the x squared plus 1, so this is left with x squared plus 1 squared. But before we're done with this problem, what else do they have in common? The coefficients. So they both could spare, each term could spare a 2. So then, ultimately, we get 2x squared plus 1 cubed x minus 8 x squared plus 1 squared. Okay? And although that doesn't look elegant, that's as much as we're going to get with greatest common factor for that example. Let's move on to a third one. So at this point, you should be familiar, I hope you're familiar, on how to do greatest common factor problems. So let's do this one real quick. Again, feel free to pause, do it yourself, and then check your answer with me when you're ready. So I'm looking at each term now. So I see the coefficients. They all have 6 as a greatest common factor for the coefficients. And let me just pull out a negative sign too while I'm at it. So I'm going to pull out a negative 6. So then I'm left with x to the 4th, y squared, and then this is a minus sign now, 3 x squared y plus 4. Okay, so pay very close attention. Since I pulled out a negative 1 with the 6, all the other terms have to compensate for that, all right? So next, I'm done with my coefficients, and I'm going to take a look at anything else. Is there anything else that I could factor out? Well, I see that the first two terms right here, x to the fourth y squared and negative 3x squared y, they share x's and y's, okay? So because of that, I could do this. So negative 6 still stays out here. I'm going to use a bracket, and then I'm going to factor things out from the first two terms in the parentheses. So let's take a look. Between those two terms in the first two terms in the parentheses, I could spare two x's, right? So I'll yank out an x squared, and then I could spare one y, okay? So if I do that, oh, let me not forget about the y, and then x squared y minus 3, and the x squared and y gets yanked out of there. Boom, close that, plus 4. Okay, and that's all there is to it. That's it. For greatest common factor, you're just finding the greatest common factor with the coefficient and the greatest common factor in each term of every single variable that you see. To this, what's a good example here, where you have this mess of the second example or even the third example where things are just, they look kind of random and haphazard. Right? Well, I know it was. So the next one, the next factoring topic is grouping. So as you could guess by the name, you're trying to group things together. So it's very much, it's kind of similar to greatest common factor, right? As you could see in the first example problem, we have two terms, and they share what in common? They share the c plus 2x, right? So the idea of this is we're trying to group things together. So the c plus 2x is a common factor. We'll yank that out. So if we yank that out, we get c plus 2x, okay? So pay attention now. We get the c plus 2x out of the first term, so we're left with a 2a, right? And then the second term, we're left with a minus 5, okay? So if you see and notice, the difference between the grouping and the greatest common factor is when you have two things exactly in common, like in this case c plus 2x, and they're both to the same power of magnitude, then you're left with this clean thing of two binomials being multiplied by one another, okay? As opposed, so with grouping, you get this kind of clean look of binomials being multiplied by one another. So let's take a look at the second example here. Not as nice as the first one, not as easy or trivial, I'll say, but it's the same idea. So let's try to take a look at the first two terms, okay? Let's try to see if we could factor anything out of there, and then we'll take a look at the other two terms, see if we could get any greatest common factors between these two. Well, 18x plus 33, well, let me rewrite that. So let me do this, 18x plus 33. That way it gives us a better visualization, okay? Plus negative 6x to the fourth minus 11x cubed, okay? All right, so let's focus and hone in on the first part. So what do they have in common? 18x plus 33. Well, I know that 3 goes into 18 and 33 equally, so I could yank out a 3. All right, that seems to be the greatest common factor between the two. Let me yank out a 3. 3, so whoops, that is not what I wanted. 3, so what am I left with? I'm left with a 6x here and an 11 here. Okay, so far so good. All right, now we're going to move on to the second set of terms in the second parentheses. Well, I see there's a negative sign. I'm going to yank out or factor out a negative 1. All right, so let me do that right now. Negative. All right, I'm not going to put a 1 because negative is just fine. They seem to have an x cubed in common, right? So when we're looking at these two terms, negative x to the fourth and negative 11x cubed, they both could spare an x cubed. So let's factor out an x to the third power. Negative x cubed. So what are we left with inside the parentheses? Well, that negative is now a positive, so we have a 6, and we're left with an x here, okay? And then that negative 11 becomes a positive 11. All right, well, now let's take a look at things. So if we pay attention on this, on what I'm underlining here, well, both of these things, these two terms now, have a 6x plus 11 in common. So what I'm going to do is I'm going to group that and factor that out. So let me get the right color, equals. So I yank out a 6x plus 11, and I'm left with a 3 minus x cubed. Okay? And as you can see, we have that nice binomial multiplication going on like we did up here. Okay, so far so good. So before we move on to the next problem, feel free to pause again, try it out yourself, and then press play again to see if you did your work correctly. Okay, so again, I'm going to group these together. Not with this color. 7x plus 7x cubed plus x fourth plus x to the 6. Okay. Now I'm going to take a look at the first set of parentheses. I could afford to yank out a 7, and I could afford to yank out an x. So what I'm left with now is a 1 here plus x squared. Okay? Let's take a look at the second set of parentheses. So x to the 4th plus x to the 6th. What do they have in common? X to the 4th. So let's factor that out. Plus x to the 4th. We're left with a 1 here plus x squared. Okay? Here's the beautiful part. Taking a look at that term and the second term. Well, looks like they both have a 1 plus x squared in common, so let's factor that out. 1 plus x squared times 7x plus x to the 4th. And that's it. That's all we have. And that's grouping. Okay? So, now that we got greatest common factor out of the way, we got grouping out of the way, let's move on to, let's say, a more generalized way of factoring things, okay? So the way that I'm going through these factoring methods in order is how you should think of things when you're looking at a problem. So when a problem asks you to factor out a long one, okay, so looking at the top expressions here, your general quadratic polynomial is so a, b, c are your coefficients, right? So ax squared plus bx plus c, that's your general quadratic equation or expression. Now for trinomials, we're going to assume that the expression that you're given or equation has that coefficient a as 1, which means you're left with x squared plus bx plus c. Okay? Now the idea when you're dealing with general trinomials is you're going to multiply the coefficients a and c. Okay? So a times c gives you a product. Okay? And then that product, you're going to want to find two numbers basically whose, okay, let me find a way to let me get my bearings straight now. So you want to find two numbers whose product is a times c, but whose sum is b. Okay? Now that might sound a little confusing right now because we're dealing with abstract things. Okay? A, B, C, these are, variables. So let's focus on trinomials. So now we're assuming that a is just 1. Well, that means we're looking for two numbers whose product is c and whose sum is b. Okay? So let's apply it with this first example. We have x squared plus 7x plus 12. Okay, so let's do that. So we want to find a product, two numbers whose product is 12, but whose sum is 7. Okay? Well, I could do this. I can make this what I call a tree. Okay? So two numbers that multiply to 12, well, I think 4 and 3. Okay? Now I'm going to ask myself, what is 4 plus 3? Well, that gives me 7. That's exactly what I want, right? The sum is 7, and the product is 12. So, what I could do at this point is, I put my parentheses here, and I say, okay, well, since this is a nice trinomial where the coefficient a is 1, I could do this. I put x here, and I put an x here. Okay? So, for expressions or equations of quadratic things, polynomials, where your coefficient of a is 1, you're always going to have this format. Two binomials that are being multiplied together with the first term of each binomial starting off with an x. Now, the second part is we're going to fill in those blanks. So x plus 4, okay, that 4 comes from here as a positive 4, and then on this one, I'm going to say plus 3. 3 is coming from here, and then 4 is associated in blue. Boom. So, and that's all there is to it. As a sanity check, let's multiply things back out. And if we multiply things back out, we should get exactly this, right? The original expression, x squared plus 7x plus 12. So let's do that real quick before we move on. X plus 4 times x plus 3 equals to, well, this and then that. So that's x squared plus 3x. And then I'm going to change the blue here. And then this goes to here. Plus 4x plus 12. Then I'm going to switch it back to, let's say, green, shall we? Let's combine like terms. X squared plus 7x plus 12. And what do you know? We get exactly the same starting expression as we did for the problem. Great. So that's a good sanity check. Whenever you're in a test or doing homework, you should always distribute out your binomials again to make sure you get the original expression or equation. Okay? So let's move on. X squared minus 4x minus 12. Well, now I am looking for a product of two numbers that give me negative 12. Okay, that's our product. And the sum of those two numbers should add up to negative 4. So again, I'm going to do my tree here, negative 12, okay? So, okay, well, 4 and 3 seem to work, but 4 and 3 added together gave me 7. That's not what I'm looking for. What else looks negative 12, or 12 in general? A 6 and a 2, right? So, let me do this. Let me just arbitrarily pick 6, and let me say negative 2, because we want to get a negative 12, right? Well, let's add those together. What does that give us? That gets us a positive 4. Ooh, close, but not quite, right? So let's do this one thing. Instead, let's multiply each number by negative 1. So I'm going to times negative 1. So that means this becomes a negative 6, and this becomes a positive 2. Now let's add these two numbers up. Well, negative 6 plus 2 gives us a negative 4. That's exactly what we want. So we're going to run with that. So again, I put my two parentheses, okay? And let me do this. Let me put placeholders, okay? Well, I'll put x here, and then I'm going to use green for this and blue for this one, okay? So We have a negative 6. So this negative 6 goes here. Let me do this. Okay. And then we have the positive 2. And the positive 2 goes here. Okay. Let me just change that because that did not look. There we go. That's a plus sign. Okay. And I guarantee you, if we distribute all that, we are going to get the starting expression equals, so again, that's x squared plus 2x minus 6x minus 12. Okay. Combine like terms. So that plus 2x minus 6x gives us a negative 4x and then minus 12. And that matches up exactly with what we started. Okay? Let's end on a general note. But again, you can't take any shortcuts with these things. You just have to know the basics and do a lot. So now we're going to talk about general trinomials. Don't get scared. It's the exact same thing that we did on the last slide. So instead of having a as 1, a could be any number now. Okay? Any number including 1. So if we go back to the last slide's logic, we said we want to find two numbers whose product is the resultant of a times c. But we also want those two numbers to add up to b. Okay? So let's apply that here. So the first thing I try to do is, let me take a look. Can I factor or group things together in each problem? 12x cubed minus 5x squared minus 3x. Well, I see an x. Let me factor out an x first. So that leaves me with 12x cubed. Nope. 12x squared minus 5x minus 3. Okay? All right. So now I am focused in on this. So let me take a look at this. I can't group. I can't factor any further. And it doesn't seem like my a is 1 anymore. My a now is actually 12. So let me just write that out. 12 times negative 3, that gives me what? Negative 36. Okay? So I'm looking for two numbers who multiply out to negative 36, but also add up to negative 5. Okay? So let me do my tree again. Negative 36. Okay, so let me see here. What can I do? 9 and 4 gives you 36, right? So let me do that. Let me do negative 9 and 4. Okay, so now we add those things up together. Negative 9 plus 4 gives us what? Negative 5. Is that what we want? That's exactly what we want. Okay, so we found two numbers who multiply out to negative 36 and add up to negative 5. So the only difference now is we're going to replace this middle term, the negative 5x, with negative 9 and 4. Okay, sorry, negative 9x and 4x, and you'll soon see why. X times 12x squared minus 9x plus 4x minus 3. Okay, well, do you see it? Okay, let me underline it for you. If we look at the first two terms and then the last two terms, we could group things, can't we? So let's do that. We're using everything under the tool belt now to factor. So the first two terms, 12x squared minus 9x, I could factor out a 3 as the coefficient, and I could factor out an x. So I'm left with a 4x minus 3. Okay? So it seems like I want to have a 4x minus 3 on the second set. But if we look at that, we already have 4x minus 3. So we don't have to factor anything out. Let's just assume we factor out a positive 1. Okay? I don't even want to have to put that 1. Yeah, 4x minus 3. Okay? So finally, what we're going to do is we are going to factor out group factor, if you will, 4x minus 3, and now we're left with a 3x plus 1. And let me get rid of that bracket. So ultimately, we have x times a quantity of 4x minus 3 times a quantity of 3x plus 1. Okay? And that's it. So you're using your knowledge of trinomials by getting the two numbers whose product is a times c and the sum adds up to b. And then you're going to ultimately use grouping at the very end to get your final factored form. Let's do one more example and then we'll call it a day. All right? So the first thing I'm looking for is, can I group anything out? Sorry, can I factor anything out from greatest with using greatest common factor? Well, I don't like a negative sign in front of as my coefficient for a, so let me yank out a -1. Is there anything else I could yank out? It doesn't look like it. So negative 4x squared plus 23. Nope, sorry, that should be a negative. That's a negative 23x minus 6, okay? So again, now I'm going to focus on that part that I underlined in green. So now I'm trying to find a product of two numbers that give me negative 24 and whose sum is negative 23. Well, this seems easy enough, right? Negative 24. So, negative 24 and 1 gives me negative 24 when I multiply it. And when I add them, that gives me negative 23. Okay? So boom, we have it. So let's do that. Equals to negative 4x squared. So remember, we're replacing that middle term, that negative 23x, by negative 24x plus x, or 1x, minus 6. Okay, now let's do group factoring. Negative, so the first two terms, let me do this. Boom, and then boom. Okay? All right, so I could yank out a 4x from the first two terms. 4x, that means I'm left with an x here, and then a minus 6. Oh, what do you know? The second two terms, or the last two terms, is already an x minus 6. So I'm going to do plus 1, okay? X minus 6. Ultimately, we could see that x minus 6 is a common factor that we could group out. Negative x minus 6 times 4x plus 1. And let me get rid of those brackets. So our final answer is 4x plus 1. And that's it. That's all there is to it. Oh, that's not what I wanted to do. I meant to highlight it. I'm sorry. And that's all there is to it when it comes to factoring. Okay? So to summarize everything, we covered 4 practice. Okay? I'll catch you on the next one. Peace.